Okay, welcome back to POE. What we're going to be discussing today is the external forces working on this truss system. And in this example, we know that we've got a couple forces. One of those forces are right here, and that is the reactionary force at point D in the x direction. I also know that up here, I have a reactionary force at point E in the x direction. And then up here at the top, I have a reactionary force, and that's at point E in the y direction. So what does that mean? Well, there's three things, hopefully, we've learned that we need to do when dealing with the external forces here. We need to do a summation of the moment. We need to do a summation of the forces in the x direction, and we need to do a summation of the forces in the y direction. Well, the moment. So I'm just going to start off here, and you can start off by listing every single one. All right? The moment at point A, plus the moment at point B, plus the moment at point C, plus the moment at point D, plus the moment at point E, all has to be equal to 0. Otherwise, this object's going to start to twist and turn. Well, what makes up moment? Force and distance. So the only ones I'm going to leave now are the ones that have a force and a distance. Well, point B, there is no force down here at point B, so I can get rid of that one. Point D, there is a moment, and at point E, there's no moment because that's where it's being pinned. If it's where it's being pinned, then there can't be a moment there. So the one here, the moment at A, is going to be 500. Now I'm going to make that negative 500 because it's going down. I'm going to backtrack actually here a little bit. What I haven't done yet is talked about which one of these moments would be positive, which one of these moments would be negative. The two 500s, the one at A and C, those moments are going to be positive because they're making it turn counterclockwise. The moment at D would be making it turn clockwise, so that would be negative. So it would be the moment of A plus the moment of C is equal to the moment at D. That's if I take that to the other side. So now I'll start putting these force and distances in. The force is going to be 500 at A. It is a distance of 4 feet away. The force at C is 500. It's a distance of 2 feet away. And then the moment at D is going to be R dx, and it's 2 feet away. Well, this gives me 3,000 over here equals R dx times 2. R dx then has to equal 1,500 pounds. And that's just using the moment. So I'm going to go over here. Now, this just gives me an absolute value, because over here the positive and the negative values that we're coming up with, and this is what some of us are struggling with in class, this is just, think of this as an absolute value. Now that I go back to the actual truss, I say to myself, R dx, it has to be pushing to the left. Why? Because the truss is pushing on it. So it's going to be a negative 1,500 pounds. R dx is a negative 1,500 pounds. So now I'm going to do my summation of my forces in the x direction. Well, how do I go about doing this? In the x direction, I've only got two forces in the x direction, x and r dx. So I can say that rex plus r dx have to equal to 0. Well, that means that rex plus negative 1,500 equals 0. If I take the negative 1,500 to the other side, we get rex equals 1,500 pounds. Now that I'm actually dealing with forces, this tells me that rex is a positive 1,500 pounds. And that makes sense. If we were hanging something from over here, if something was hanging from over here, whether it be a sign or something, it really wouldn't matter. What would happen then is over here at force x, the wall would have to be pulling back because this object would be wanting to pull away from the wall. So 1,500 pounds is pulling it towards the wall or in the positive direction. Likewise, down here at the bottom, there's going to be a force that's pushing to the right. So RDX is going to have to be pushing back to the left. The wall is going to have a reactionary force of pushing back to the left, and to the left is a negative direction, so it's negative 1,500 pounds. Now, I have to do my summation of the forces in the y direction. Well, at point A, I've got a 500 pounds, it's going down, so it's negative 500. The next one is negative 500. And then as I make my way across here, I have the reactionary force at point E in the y direction. Well, this gives me negative 1,000 plus the reactionary force at point E in the y direction equals 0. Take the 1,000 over the other side, and we find out that there's a reactionary force at point E in the y direction of 1,000 pounds. Alright, this is our simple little video over the external forces. Remember that the first thing we have to do when we come to these trusses, we've got to take care of our external forces. And maybe I haven't done a great job of that, probably haven't because we're still pretty confused. But our external forces are the first three things we're going to do. We're going to take care of the moment, we're going to take care of the external force in the x direction, and we're going to take care of the external forces in the y direction. Hopefully that helps clear up some of our